Hi guys, this is Achut. So we are going to be solving today's lead code question, which is farthest building you can reach. So the question states that we are given an array of heights and we need to find the farthest building we can reach by using certain operations. Suppose let's say we want to move from building I to building I plus 1. Then there can be three scenarios. Like suppose if the height is greater than or equal to next building, then we don't need to use any bricks or any ladder. We need to just jump from higher building to low building. So the number of ladders and the number of bricks used for this operation is going to be zero. And then let's say if the building at the current position is less than the next building, as as we see in this particular picture, like we need to add some bricks here and then we need to get on top of this and then move to the next building. And one more thing is we can use ladder. The ladder you can assume like it can have like the big like let's say it is 10 power 5 and then it can be 1, it can be 2, it can be 3, it can reach any type of building from here to here. And then again let's say you have used one ladder here, then you cannot get back from the top the same ladder and then use it again. So the ladder should be in such a way that it is non reusable. So that is the case, and we need to find the rightmost building we can reach. That is the question. So if we try to think of a solution, there is going to be three scenarios, which is height of high is greater than height of I plus 1. For this, we are just going to continue, and then let's say if the height of I double equal to height of I plus 1, then for this uh, the ladders and then bricks used will be 0. Let's say height of I is less than height of I plus 1. Then for this we can use one ladder or number of bricks will be height of I plus 1 and then height of I. So we can use any one of this case. It can be one ladder or it can be number of bricks. So let's take the example and then figure out like how can we solve this. So let's take this example. Let's say this is the particular question and then we were given bricks equal to 5 and and then ladders equal to 1. Now let's try to build the array. Let's say for this from 4 to 2, the number of bricks required will be 0. Let's say you want to move from 2 to 7, then the number of bricks required will be 5. And then for this one, as it is 7 is greater than 6, then it is going to be 0. And then 6 to 3, it is going to be 3. And then 9 to 14, it is going to be 5. And then like 14 is greater than 12, so it is going to be 0. And then for last, it is going to be 0. Yeah, these are the number of bricks required when we want to move from current building to the next building. Let's say we have ladders. So when should we use ladders? When should we use ladders? Let's say I got 1, 2, 3, 4, 5, 6. Let's say I have only 5 ladders. Let's say I have only one ladder, and these are the number of bricks which are required right now. So for this particular case, if we use ladder for this particular case, then the number of bricks is going to be 2 plus 3 plus 4 plus 5 plus 6. So this is going to be more. And then if we use for 2, then it is going to be 1 plus 3 plus 4 plus 5 plus 6. And if we use particular 6, then the number of bricks required will be 1 plus 2 plus 3 plus 4 plus 5. So whenever we use the number of bricks are higher, for that particular case, if we use the ladder, then it is going to be the better case. Ladder will be used for more number of bricks. Okay. So ladders will be used for more number of bricks. Let's say we'll not be having like sorted. Let's say 1, 2, 3, 4, 5, 6. Here it is sorted. Then you can say the last element is going to be the ladder. But if we observe this particular case, for this particular case, it is unordered. So we need to get the maximum elements that can be stored on top of the ladders. Let's say 5, 4, 3, and then 2. We'll have ladders list, which is ladders list, and then we'll add on top of this. Let's say we have empty right now. Now we want to add on the ladders list. Now let's take this particular case. If you want to add here, then ladder list is going to be 5, and then again we are going to add here 3. So the ladders list is going to be 3. And now if the maximum ladders we can use is 1, then we are going to remove one particular element. So which is the element which we want to remove? It is going to be 3. So we want to remove the minimum number which is present in the ladders list. And then whenever it reaches size is greater than number of ladders, then we are going to remove that particular case. Sup- Suppose for this particular case we are going to use minimum heap. Why? Because it is going to store all the elements which are present, and then whichever element is minimum out of the all particular list, it is going to return, and then we are going to pop that particular element, and then we can use this particular element for the bricks, and then we'll see the scenarios. So let's see the solution. So this is a syntax for minimum heap in C++. So it might be different for Python, it might be different for Java. Check it out. So I'm taking used bricks is going to be 0, and then I'm traversing from 0 to ith size, and then it is going to be I++. So whenever we reach heights I is equal to last, then we are going to return I. And then let's say if the heights of I is greater than or equal to heights of I plus 1, then we can directly jump or we can move. So we are going to continue for this particular case. And then one more thing is, when we need certain amount of bricks, so we are going to be pushing into the minimum heap. And then whenever we have a minimum heap size greater than or greater than ladders, then we are going to take out the minimum number of bricks present in the particular list, and then we are going to use the used bricks, and then we are going to pop the particular element which is present in the ladders list. And then let's say if the used bricks is greater than whatever the bricks which we are given, then we cannot move to the next building, so we'll be returning the I, and then at last we are going to return height size minus 1. Anyhow, it will be cached here only. I is equal to height size minus 1. So let's run this. So we are not doing much anything here. We are taking the minimum heap, and then we are checking the heights, and then we are pushing into the minimum heap. And if it is greater than ladders, we are going to use it as a brick. And then if the used bricks is greater than the bricks which are given right now, we are going to return the whatever the index of, of the building, and then at last we are going to return height size -1. So let's run and then submit. So let's submit this. So if we consider the time and space complexity, as we are using extra space, which is going to be this particular ladder size, which is going to be n. So the maximum priority queue size is going to be n. So it will be big O of n. And then time complexity is going to be for insertion and then popping of all the elements. It is going to be big O of n for the minimum if. And then as we are doing for like n, it is going to be n log n time complexity. Yeah, that's all for this video. Thanks for watching.